Okay, so starting this part with deriving tangent of a sum. So as we know, tangent is equal to sine of an angle divided by cosine of that angle. In this case, we do have a sum, so it's sine of u plus v divided by cosine of u plus v. We're going to use both of these identities, cosine of a sum and sine of a sum, to derive the tangent of a sum. So I'm going to restart my work over here. Okay, sine of u plus v is going to be sine u cosine v plus cosine u sine v divided by cosine u cosine v minus sine u sine v. Then we're going to go ahead and see what we can do to manipulate this expression. Let's see. I have, or what I want to get to is having tan u and tan v in the numerator. So I don't want cosine of v in here, and I don't want, let's see, cosine or sine of v in here either. So I'm going to go ahead and manipulate my expression so I can end up with tangents. To end up with tangent, I have to multiply by values that create tangents in both. So that means multiply the top and the bottom by 1 divided by cosine u. So I can have sine divided by cosine, and that would be tangent. And then also cosine v. Okay. And same thing at the bottom, 1 divided by cosine u cosine v. Let's see where that takes us. Okay, so we distribute for the first term. If I multiply this by 1 over cosine u cosine v, I'll end up with sine u after simplifying divided by cosine u plus sine v divided by cosine v all over. Now onto the denominator, same thing. Cosine u cancels out, and we're going to have cosine v divided by cosine v. So both of those actually cancel out. Minus, we're going to have sine v. It's going to be actually sine, nothing cancels out in this one, sine u sine v divided by cosine u cosine v. So all I did over here is took this expression in the numerator and distribute it to this term and to this term by multiplication, and then did the same thing with the denominator to that term and to this term as well. Okay, and we further simplify. So sine u divided by cosine u is tan u plus sine v divided by cosine v is tan v divided by cosine v divided by cosine v is 1 plus sine u divided by cosine u right here. This quantity is tan u, and then the next one is sine v divided by cosine v is tan v. This concludes our proof. This last proof is tan of a difference, so it's going to be sine of the difference divided by cosine of the difference. Okay, and Actually, I don't want to go with this route. I'm going to do this a little bit differently. Instead of looking at tangent of a difference, I'm going to switch the tan of a difference to a tangent of a sum. We do know tangent is an odd function. Actually, not even that. I'm just going to turn subtraction into adding the opposite. So forget everything I said. Tangent of u plus a negative v. Okay. And now I can actually use the identity that I just proved right before this one, which is tangent of a sum. And that would be tan u plus tan of negative v divided by 1 minus tan u tan negative v. Okay, simplify further. We've got tan u. We know tangent is odd, so therefore I can take this negative out and place it in front of tan. So tan is odd, so making the plus a minus, tangent of v. Same thing in the denominator, it's going to be 1 minus tan u, and then tan of negative v, so take the negative out, and that makes the subtraction into addition. So tan u, tan v. That's the end of this proof as well, and I'll leave you to figuring these two out on your own.